Today we will be doing a chapter, Laws of Motion. See, you have already been introduced to the very famous Newton's laws of motion when you were in class 9 and 10. So there is perhaps no need to be reintroduced to those laws, but today we will discuss certain features of those laws which were not taught to you in the lower classes. First of all, imagine there is a block . Imagine there is a block and it is resting on a horizontal surface. So there is a horizontal surface and on this surface there is a block. The block is resting on this horizontal surface. In this particular situation, how many action-reaction pairs can we identify? Let us discuss that. So the first action-reaction pair the earth is pulling this block with a force W, which we call weight of the block. So you could also say that W is the pull of the earth, and the block in turn will pull the earth with an equal and opposite force W. So I repeat once again, the earth will pull this block with a force W, which we call weight of the block, and you could say that W is the pull of the earth on this block. The block in turn will pull the earth with an equal and opposite force W. Well, you all know that compared to the size of the earth, this block is too small to have any effect on the earth. But these two forms a action-reaction pair. Secondly, the block will exert a force N on the surface. So N is action of block on the surface, and there will be a reaction. So N is normal reaction of surface on block. So once again, this N is the action of block on the surface, and this N is the normal reaction of the surface on the block. So we are very used to terms like weight, normal reaction. So whenever there is a body near the surface of the earth, we refer to the pull of the earth as weight of the body. Whenever you have a body placed on any surface, we refer to the force of the surface on that body as normal reaction. So we will continue using these terms, but it is important to understand that the action-reaction pairs are NN and WW. You should not think that W is action and N is reaction. That is wrong for two reasons. First of all, if W is action and N is reaction, then how can they both act on the same body? Because you have learned in laws of motion in class 9 and 10 that action and reaction never act on the same body. So if W and N are action and reaction, it is fundamentally incorrect because they both will be acting on the same body, which is this block. And the other thing is that W and N, if you consider them as acting on this block, then you will see that W and N have to be equal and opposite. Why? Because the block is at rest. So there is no doubt that W and N are equal and opposite, because That is why the block is at rest. And in fact, according to Newton's second law, if a body is at rest, that means the net force is 0. So you can see this block is at rest, so net force has to be 0. So W and N have to be equal and opposite. Now, when you draw a diagram like this, it is called a free body diagram. Now, what does free body diagram do? Free body diagram, it takes one component of any system and views it in isolation. So you take this block, which is a component of this system, and just look at the block in isolation, which means analyze all the forces acting on this block, and when you do that analysis, you find that W and N are equal and opposite. So free body diagram allows you to come to these conclusions by simply analyzing each component of the system individually. So what is the definition of free body diagram? You can write down. A free body diagram is a diagram which views in isolation all the forces acting on a particular component of a system. So this was a very interesting discussion about action-reaction pairs, and it also led to one important term which we have learned today, that is free body diagram. Now suppose there is a block, right? There is a block. It is suspended by a massless string. This string is absolutely massless and it is attached to the ceiling. So this block is suspended from a massless string and attached to a ceiling. Question is that you have to find out all the action-reaction pairs. Now, as usual, W will be the pull of earth on block, and by now you know that equal and opposite W will be pull of block on earth, right? So W is the pull of the earth on the block, and equal and opposite W is the pull of the block on the earth. Second thing is that the string is holding the block up. So let's say the force between the string and the block is T1. So T1 is pull of block on string, and T1 is pull of string on block. So I repeat once again, T1 is pull of block on string and T1 is pull of string on block. So this is the second action-reaction pair. And now what is the third one? Let's have a look at that. T2 is pull of ceiling on string, and this T2 is pull of string on ceiling. So I repeat once again, this T2 is pull of ceiling on string and this T2 is pull of string on ceiling. So we have managed to find out three action-reaction pairs in this particular situation. W and W between the earth and the block, T1 and T1 between the block and the string, and T2 and T2 between the string and the ceiling. So there are three action-reaction pairs which we have found out in this particular situation. Now we have learned one new topic, that is free body diagram. So if you draw the free body diagram of the block, let's say you draw free body diagram of the block, so you can see that there are two forces one is W, that is due to the earth, and the other is T1, that is due to the string. Are these two forces equal and opposite? Yes. How do we know that? Because the block is at rest. So the block is at rest means the resultant force on the block must be 0. That is why T1 is equal to W. Now let us have a look at free body diagram of the string. So these are the two forces. T1 is the force on the string exerted by the block, and T2 is the force on the string exerted by the ceiling. Are these two forces equal and opposite? Yes. How do we know that? Because the string is at rest. Another thing is, in this chapter you will find that in virtually all numericals the string will be considered as massless. So anything which is massless is incapable of having a force on it, because F is equal to ma. If m is 0, force is automatically 0. So you will always, in all such scenarios, you will always get T1 and T2 equal and opposite, because this string is incapable of having a force exerted upon it, simply because its mass is 0, or we have considered its mass to be 0. Now this T1 or T2, they both are called tension in the string. So tension is the response of the string to any force on it. So when the block is pulling the string, the response of the string is T1, and when the ceiling is holding the string, the response of the string is T2, and this T1 and T2, they are equal to each other and they are called tension in the string. It is very important to understand that the direction of tension depends on the point of view. If you are talking in terms of the block, then the tension will be downward, but if you are talking in terms of ceiling, then the direction of tension will be upward. So it's very simple, but you need to observe very minutely in any situation what is the response of the string to a given external force, and that will make you understand what is the direction of tension. So let us have a look at a couple of questions using free body diagram. For example, there is a question, there are two blocks, both are having a mass m, and one of them is pulled with a force F, and the string is massless, and the question is that what will be the tension? That is the question. So you have to find the tension. Now in this particular question, if you draw the free body diagram of this block, then the forces will be F and T, and the resultant of them will be mass into acceleration. If you consider this block, then the force on this block will be simply T, and you can see that since both the blocks are going to accelerate, in both cases resultant force will be mass into acceleration. So here F minus T is ma and here T is ma. Now the question is, you have to find T. Sorry. You have to find T. So F minus T equal to T. So T is equal to F by 2. So this will be the tension in the string. So we got the answer by drawing two separate free body diagrams for the two masses and applying the Newton's second law, resultant force equal to m into A. Let's have a look at another question which is involving free body diagram. Suppose these are two blocks and this is 0.2 kg, this is 0.3 kg. You have to find the tension in both the strings. So there are two strings. There are two strings, you have to find the tension in both of them. If you consider the free body diagram of the lower block, the tension is T2 and obviously the weight will be 0.3 into gravity, so it is coming to 3 newtons. So we can now look at this diagram and say that from the equilibrium of the block, T2 will be 3 newtons. Now let us try to draw the free body diagram of this other block. For this other block, you have total upward force will be T1 and downward force will be weight of the block, that is 0.2 into G, and the tension T2, which is 3 Newton. So the total upward force will be T1 and the total downward force will be 3 plus 2, that is 5 Newton. That means in this particular question, the tension in the upper string will be 5 Newton and tension in the lower string will be 3 Newton. So this is another example of how to apply free body diagram. Next we come to one topic that is called pseudo force. Suppose there is a elevator or a lift and let us say that this lift has transparent door walls, so you can see from outside, and let us say that it is accelerating at 2 meters per second square upwards. So there is a lift which is accelerating upward at the rate of 2 meters per second square. There are two people, one person is inside the lift, one person is on the ground. Both of them are looking at a ball which is falling freely inside the lift. You have been told that acceleration due to gravity is 10 meters per second square. The question is, with all this data, you will have to say what is the acceleration of the ball as seen by this person, number 1, and what is the acceleration of the ball as seen by this person, number 2. Now the thing is, if you just follow your basic knowledge of relative motion, you will realize that this person is looking at the ball as a freely falling object. So this person will give the answer 10 meters per second square. Because for this person, the ball is a freely falling object, so he will give the answer which is equal to acceleration due to gravity, so he will say the answer is 10. Now the thing is that for this person, what will happen is that the acceleration of the lift is upward, whereas gravity is downward. So in relative terms, the answer given by this person will be 10 plus 2, that is 12 meters per second square. So using the concept of relative motion, the answer given by this person is 10 and this person is 12. Now Isaac Newton gave another suggestion for doing such a question. According to him, the person who is on the ground, he is supposed to be on an inertial frame, and the person inside the lift, he is supposed to be in a non-inertial frame. So the frame of this person is inertial and the frame of this person is non-inertial. According to Isaac Newton, what you have to do is, whenever the observer is inside a non-inertial frame, you will have to apply an acceleration equal and opposite to the acceleration of the frame. So the acceleration of this lift is 2, so you will have to apply an acceleration of 2 opposite to this, that means downwards. Now this acceleration is called pseudo acceleration. Why does this acceleration have to be applied? Because the frame of this observer is accelerating. If you apply the pseudo acceleration, then you can consider this frame also as inertial, which basically means that apart from the acceleration due to gravity, this ball will additionally have a pseudo acceleration of 2, and the total of these two will become 12, and in fact that is the answer to this question. So just make a note about pseudo force. You can note like this: Newton's laws can only be applied if the frame of reference of the observer is inertial. If the frame of the observer is non-inertial, a pseudo force must be applied to make the frame inertial before Newton's laws are applied. So by applying this pseudo acceleration, we have been able to make this frame inertial, and now we can easily apply the Newton's laws. So this is an example of pseudo acceleration. Let us have a look at a question related to pseudo acceleration, just to get an idea. Suppose there is an elevator and it has a pendulum bob of mass 50 grams, and there is a string with which the bob is suspended from the ceiling. So question is that what will be the tension of the string if the elevator goes up with an acceleration of 1.2 meters per second square. Okay, so I repeat, the question is what will be the tension in the string if the elevator goes up with an acceleration of 1.2 meter per second square. Now if the elevator is going up with this acceleration, that means the frame of the lift is non-inertial. So to make the frame inertial, you will have to apply a pseudo acceleration of 1.2 meters per second square. This will apply downwards. So T is equal to 50 by 1000 into 9.8 plus 1.2. Why is that so? Because the frame of this elevator is non-inertial. So to make it inertial, you have to apply a pseudo acceleration whose value will be 1.2. So the tension will be equal to 50 by 1000 into 9.8 plus 1.2, and in fact that will give us the answer to this particular question. Now if the same question it was written that the elevator is going down with an acceleration of 1.2, instead of going up, suppose the elevator is going down with an acceleration of 1.2, then the pseudo acceleration will be 1.2, but it will act upwards. So in this case the tension will be 50 by 1000 into 9.8 minus 1.2. So this will be the answer if the elevator is going down with an acceleration of 1.2. Now suppose in the same question you were told that what will be the tension if the elevator is going up or down with uniform velocity. Now you know that uniform velocity does not count as non-inertial frame. In fact, you can just make a note of this, that a non-inertial frame is an accelerating frame, full stop. For terrestrial calculations, Earth is considered to be inertial frame. So if the frame has upward or downward velocity, it will very much be a inertial frame, right? And when I say terrestrial calculations, if the observer is on the surface of the Earth and looking at some motion, then that will be considered as terrestrial calculation. In that case, the frame of the observer, we will take it to be inertial, right? So if the lift is going up or down with uniform velocity, then tension will simply be 50 by 1000 into 9.8. Then we don't have to apply any pseudo acceleration at all. it will be 50 by 1000 into 9.8. Now we will discuss this topic, that is pulley systems. You know that pulley systems are a very integral part of Newton's laws. Suppose this is a massless pulley and there are two masses. This is M1, this is M2, they are both placed in this manner. Now the thing is, the question is that what is the tension, and by the way M1 is 300 grams, it has been told, and M2 is 600 grams. So this information has been given, M1 is 300 grams and M2 is 600 grams. Now the thing is that in this particular situation, you have to find the tension in the string, number one, and you have to find the force exerted by the clamp on the pulley. Clamp means this one. Now you can see that in this particular diagram, this one is heavier than this, so this will go down, this will go up. So we can draw a free body diagram, but it's pretty obvious, so I'll straight away write it, that 0.6 g minus t is 0.6 into a. This will be the equation of motion for this block. 0.6 g minus t is 0.6 a. Now for this block, the equation of motion will be t minus 0.3 g is equal to 0.3 a. So for this block, 0.6 g minus t is 0.6 a, and for this block, t minus 0.3 g is 0.3 a. Now the thing is, if you multiply this with 2 and then if you subtract the two equations, then you will get t is equal to 0.4 g. So 0.4 into g is equal to the tension in the string. So the tension in this segment of the string as well as this segment of the string will be 0.4 g, and what will be the force exerted by the clamp on the pulley? You can see that will be double of t. So the answer will be 0.8 g. So we have got a basic idea of how to handle pulley systems, and the pulley is considered massless, string is considered massless. Pulley is considered massless because if the pulley has a mass, then the rotational motion of the pulley will also have to be taken into account. So for simplicity in this chapter, all the pulleys will be massless. So you write equation of motion for the heavier body which is going down, equation of motion for the lighter body which is going up, and solve them to find the tension or acceleration whichever is required. So this is one example of how to apply pulley systems. Now in this pulley system question, both the blocks were in vertical motion, but sometimes one of them or both of them may be having horizontal motion. Like say for example, look at this diagram. Suppose there is a mass m1 and a mass m2, and a force has been applied. This force value is given as m2g by 2. A force has been applied on m1, and the tension in the string is T. So the question is, what is the acceleration of m1? And all the contact surfaces are given to be smooth. Now in this question, it is very important to note that this body will move in a horizontal manner, whereas this body will move in a vertical manner. Now, because this body will move in a horizontal manner, we can say that the motion of this body is given by T minus F is equal to m1a, and this body will move vertically, so m2g minus T is equal to m2a. So for this body T minus F is m1a, and for this body m2g minus T is m2a. Now the question is that you have to find the acceleration of m1, so you have to basically find a. So for that you just add the two equations, so m2g minus F is a into m1 plus m2. So F itself is m2g by 2, so m2g by 2 is a into m1 plus m2, so a will be m2g by 2 into m1 plus m2. So this is the acceleration which is required. So you first write the equations of motion for the two bodies separately, then you add them or subtract them as the requirement is. Here the requirement is acceleration, so it's better to add them. Put the value of F, so the acceleration will be m2g by 2 into m1 plus m2. So this is an example of pulley system where one of the bodies is moving in a horizontal manner. Now the third kind of pulley system is on an inclined plane. Suppose you have an inclined plane, and on this plane there are two bodies, both are having a mass of 1 kg, and the length of the incline is 3, 4 and 5. So you have to find the acceleration of these two blocks, that is what you have to find. So in this case you say that suppose the tension in this string is T. Now before we start discussing the question, one fundamental thing has to be discussed. In any inclined plane, the block which is kept on the plane, let us say this block has a mass of m, so the weight of the block will be mg. So the weight of the block will have two components. One will be normal to the plane, that is mg cos theta, and the other one will be along the plane, that is mg sin theta. If there is no friction, then this component becomes redundant, but this component is the one we will use for calculations. So in this particular question, suppose this is theta. Now obviously this is a right angle, so this will become 90 minus theta. Now when you are talking about the motion of either of these two blocks, you have to see that for this block, let us say that it is going up, so T minus mg sin theta is equal to mass into acceleration. M is 1 kg, so T minus g sin theta is 1 into acceleration. Now if this is going up, this will certainly go down, so 1 into g sin 90 minus theta minus T is equal to 1 into A, right? So these are the calculations. So the first equation, if you look at this diagram, sin theta is 4 by 5, cos theta is 3 by 5. So T minus 4 by 5 g is equal to A, and if you look at the second one, then 3g by 5 minus t is equal to a. Now the question is that you have to find out what is a. So if you just add both of them, then a is minus g by 5. You do not have to worry about the negative answer. Negative answer simply means that the sense of direction which we have assumed, the actual answer has an opposite sense. We assume that this block is moving up and this block is moving down, but it's actually the other way around. This block is moving down and this block is moving up. That is the reason why we got a negative sign. The negative sign is not to be interpreted in any other way. That is the only meaning that it has. So the question is that acceleration of the block, and answer is it will be equal to g by 5. Have a look at this question. See, in this question, the situation is that there is a block of mass m. It is placed on an inclined plane of angle 30 degree, and this is a pulley that is on the plane, and there is another hanging pulley with the string clamped over here. This mass is 2m. So this is the situation for this particular question. The question is, you have to find the acceleration of this block, the block which is on the plane. You have to find the acceleration of this block. That is the question. Now, how do we do these type of questions? First of all, it's very important to know that here the string has been clamped. So this is like a fixed position. So what we can do is that we can have a look at what are the other fixed positions. The other fixed position is the location of this pulley. So suppose the distance from the center of this pulley to this mass is L1, and suppose from this point to the center of this pulley the length is L2, let us say, and let us say that since these two are fixed, this distance is a constant of A. So it's pretty clear that this segment from here to here, the length will be L2 minus A. Now, what is the total length of the string? L1 plus L2 minus A plus L2, and we can say without any hesitation that it will be constant. So L1 plus L2 minus A plus L2 will be constant. If you differentiate this equation once, then V1 plus 2V2 is 0, and if you differentiate it twice, then A1 plus 2A2 is 0. This means that A2 will be minus of A1 by 2. Now there is no need to get unnecessarily worried about the minus sign. You see, if this block goes down, this block will go up, but if this block goes down, this block will go up. So if one of them is moving farther away from the fixed point, the other will come closer to the fixed point. So that is why the minus sign is to be interpreted in that sense. It has no other meaning. So how exactly will we carry this information while doing the sum? We will simply say that the acceleration of this block is equal to, suppose, A, then the acceleration of this block will be half of A. That is all that we will carry from this equation. So keeping that in mind, the motion, let us say this block is going down, so its weight is 2 mg. Naturally, there are two segments each having tension T, so the support on this block will be 2T. So 2 mg minus 2T will be equal to 2m into half A. Like I said, if this acceleration here, this will be half A. So 2 mg minus 2T will be 2m into half A. If you are talking about this block, then T minus mg sine theta, because if this is going down, this has to go up, is equal to m into A. So once again, let us summarize the equation of motion for the two blocks. For this block, 2 mg minus 2T will be 2m into half A. We are assuming that it's going down. For this block, if this is going down, certainly this is going up. So T minus mg sine theta will be equal to ma. So we can rewrite the two equations like this: 2 mg minus 2T is equal to ma, and T minus mg by 2 is equal to ma. So the question is, you have to find A. So I guess the best way of doing it is that you multiply the second equation with 2 and then you add both of them. So if you do that, then A is coming to g by 3. In fact, that is the answer. The acceleration of this block will be equal to g by 3. So the method that we used to find the relation between acceleration of this block and this block, that method is known as constraint equation. So constraint equation is a very useful method to find out the relation between acceleration of two blocks which are attached to two different pulleys, like it happens in this particular question. Let us have a look at another instance of pulley. There is a mass m1 attached to a pulley kept on a table, and there is another two masses m2 and m3 attached to a pulley like this. Now here what has happened is that it seems that these two are moving with this pulley as a system, and this one is attached only to this pulley. So how do we analyze the motion in this case? So first of all, this block will certainly go to the right. Suppose the acceleration of this block is equal to A0. Now if this block goes to the right with A0, then this string will go down with an acceleration of A0. But between them, or rather relative to each other, one of these blocks will go up and the other will go down relative to each other. So what we will do is we will assume that this block is going down. So let us say its acceleration is A0 plus A. So this block will go up. So its acceleration will become A0 minus A. Another thing is that if the tension over here is T, then it's pretty clear that the tension in each of these will be half of T. Now the question is, you have to find A0, that means you have to find the acceleration of this block. So let us first write the equations for each of these blocks. First for this block. So for this block, tension is m1 into A0. Next, let us write the equation of motion for this block. So it will be m2g minus t by 2 is equal to m2 into A0 minus A. Now let us write the equation of motion for this block, so it will be m3g minus t by 2 is equal to m3 into a0 plus a. So we have written the equations of motion for each of these blocks separately, and now what we have to do is we will have to solve these equations among themselves, and while solving we will have to eliminate t and a and get a0, and if you do that then this is the answer that comes. So I repeat once again, after writing the equations of motion for the three blocks, what you will have to do is you will have to eliminate t and a, and once you have eliminated t and a, you will have to find out a0, and whatever is a0, that is the answer. Okay, now we will be discussing one topic. That is center of mass. Suppose there is a system of masses. Let us say their masses are m1, m2, m3, and they are belonging to certain positions whose coordinates are x1, y1, x2, y2 and x3, y3. So there are three masses m1, m2, m3, and their coordinates are x1, y1, x2, y2 and x3, y3. Now the thing is that the center of mass of this system is denoted by xcm. It is given by m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. So the center of mass of these three is m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Then the y coordinate of center of mass YCM is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. So whenever you have a distribution of masses, you can find the center of mass by using this formula xcm and ycm. Now let us say that instead of x coordinate and y coordinate, you are given the position vector. So what I mean to say is that the masses are m1, m2, m3 and their position vectors are r1, r2 and r3. So in that case RCM is m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. So in terms of position vector, the position vector of the center of mass will be m1 r1 plus m2 r2 plus m3 r3 by m1 plus m2 plus m3. Now, for simplicity, let us say that there are two masses and their position vectors are r1 and r2. So RCM will be m1 r1 plus m2 r2 by m1 plus m2. So RCM will be this. If you differentiate both sides, then VCM will be m1 v1 plus m2 v2 by m1 plus m2. This is VCM, the velocity of center of mass. If you differentiate both sides again, you will get ACM is M1A1 plus M2A2 by M1 plus M2. So I repeat, if you consider two masses M1, M2, position vectors are R1 and R2, then RCM is this, differentiate both sides, VCM is this, differentiate both sides, ACM is this. Now let us say that in a given situation these two masses do not have any external forces, they are only under each other's internal force. In that case, what will happen is that the force on this mass will be equal and opposite to the force on this mass. So suppose the force on this mass is F, then the force on the other mass will be minus F. So if you replace A with F by M1, then you can replace A with minus F by A2 with minus F by M2. So A1 will become F by M1 and A2 will become minus F by M2. So divided by M1 plus M2, and you will see that the answer of this comes to 0. Now this is actually a manifestation of Newton's first law. Newton's first law says that if there is no external force, then the body will continue with its state of rest or uniform motion as before. So in this scenario, if these two bodies of masses M1 and M2 do not have any external force and the only force between them is internal, in that case the acceleration of center of mass will be 0, which means that if these two bodies were originally at rest, then they will continue to be at rest. But if they were having some motion with a particular velocity, let's say, then they will continue moving with the same velocity. So this is actually a manifestation of Newton's first law. Now it may seem like a very simple concept, but it has tremendous usage. Like what it means is that suppose there are two bodies, one of them the mass is small m and the other one mass is capital M, and they both are coming towards each other and the distance between them is, let us say, L. Suppose L is the distance between them. So what will happen is, let us say this is the center of mass. So this distance is L1, this distance is L2. So we can, if you call this distance as positive, we can take this as negative. So we can say that m into L2 minus m into L1 by capital M plus small m is 0. If you take this as the origin, then m into L2 minus m into L1 is 0. So L2 by L1 will be equal to small m by capital M. So now we are in a position to say that L2 will be small m by small m plus capital M into L, and L1 will be capital M by small m plus capital M into L. So you can see that what is the tremendous usage of this concept of center of mass, that we can say that suppose these two, small m and capital M, now start approaching each other. So when they both start approaching each other, then at any point of time we can note that the movements that they make will be in the inverse ratio of their masses. Why? Because the center of mass will remain at rest, because it was initially at rest. In other words, these two will finally meet each other at the center of mass. So L2 by L1 is small m by capital M. That allows us to calculate L2 and L1 in terms of capital L, and it also tells us that eventually when these two bodies meet each other, they will meet each other at the center of mass. So this completes the topic center of mass, and it also completes today's class. We will discuss in some later class how to find center of mass of continuous distributions. These are all discrete distributions. How to find center of mass of continuous distributions will involve calculus. We will do it in some later class.